Hello, in this video I'll be going over the 2002 question 2 shuffling of the British Informatics Olympiad round 1. Alright, so first thing we should do is read the question over carefully. Question 2s often have quite a lot of content. If you miss a single trick, it'll often be quite difficult to solve them. Okay, so before playing a card game, you usually shuffle the cards to mix them up, but how jumbled do they really become after a few shuffles? The task for this question is to simulate the shuffling of the pack of cards. Simulation will be a pack of 8 cards, starting the cards in order from top to bottom. 1, 2, 3, 4, 5, 6, 7, 8. Okay, immediately just tell me we can set this as an array or a list right before we start doing anything, and then we can do this manipulations. This is just my initial thoughts, like as I was solving this. Okay, first shuffle is the break, where the top card is simply placed in the bottom of the pack. After the shuffle, the cards will be either 2, 3, 4, 5, 6, 7, and 1. So, okay, this is again also fairly simple. You remove the first item of the array, and then you append it to the end of the array. That's what the break does. Next two shuffles are ripples. In these shuffles, the pack is split into 2 equal halves, top 4 cards and the bottom 4 cards, and then the 2 halves are interleaved. In the out riffle, the card that was previously top stays top. After this shuffle, the cards be the order 1, 5, 2, 6, 3, 7, and 4, then 8. In the in riffle, the card that was previously top will become the second card. After this shuffle, the cards will be in the order 5, 1, 6, 2, 7, 3, 8, and 4. Alright, and here you can see a couple of diagrams showing us how these shuffles work. So you can see the order after O. So you have 1, 2, 3, and 4 on the left, 5, 6, 7, 8 on the right, and 1 is on top of 5, 2, etc. The order after I mean, initially it actually looks quite similar. Just looking at it, you have numbers 1, 2, 3, 4, 5, 6, 7, 8. Except your 5, 6, 7, 8 are above the 1, 2, 3, 4. And this kind of suggests that the functions for doing O and the functions for doing I are identical. Alright. The 3 basic shuffles can be combined to make more complex shuffles. Shuffles are described as follows. The 3 basic shuffles are denoted by BIO. The shuffles are written in the order they should be done. A number can be put before basic shuffle to indicate it should be done several times. A complex shuffle can be put in brackets, and a number put before the brackets indicating the complicated shuffle should be done several times. For example, IO is the in riffle followed by the out riffle. 4B is a sequence of 4 breaks. 4BIO is a sequence of 4 breaks followed by an in riffle then an out riffle. 4BIO means repeat the sequence break, in riffle, out riffle 4 times. Okay, so in these 3 examples, let's just look at the bits which are repeated, and let's just highlight what's repeated here. B here, B here, BIO. And so you can see when a number is placed without brackets after it, you only repeat the letter after it. And when a number is placed with brackets after it, you have to go through, find the end of the bracket, and then the expression that you get is you repeat 4 times. Okay, so the question is, write a program that shuffles a pack of 8 cards. Your program should first read in a single line containing a description of the shuffle. This line will have less than 20 characters and any numbers will be between 2 and 9 inclusive. Alright, so what this tells us is that we can assume that if we find a digit, it's either going to be followed by a letter or a bracket. And this makes sense because if you have 2 digits one after the other, it's a 2-digit number. Descriptions will meet rules 1 to 4, these rules. In other words, all numbers will be followed by a letter or bracket, so it specifies that here, and all brackets will contain complex shuffles. You should apply the shuffle to a pair of 8 cards, and then output the final order of the cards. Alright, so let's look at this in slightly more detail then. So we have our pack of 8 cards. 1, 2, 3, 4, 5, 6, 7, 8. And then what we have to do is say, let's take the sequence here of this sequence because it looks more complicated. This one, okay, let's just go over this quickly. I to O. Oh, oops. For this one, what we're going to do is say I goes first. So when we're reading in the string, we take I first, do that, and I mean we can just use the question. The question gives us what happens when I happens. 5, 1, 6, 2, 7, 3, 8, 4. Okay, and then you're reading this number 2. So what happens here is 2 doesn't do anything by itself. It's what comes after 2 that really changes things. So if we look at the next character, that's going to be O. Because it's not a bracket, we know we're not repeating the complex shuffle. Therefore, we repeat the O shuffle 2 times. And after this, we're given that the end result is 5, 6, 7, 8, 1, 2, 3, 4. Yeah, so what we do, we read each character in. If it's a letter, we do the shuffle. If it's a number, we look at the character next to it. And if it's, I mean, at least if it's not a bracket, we can just repeat next instruction the amount of times the number says. There's no way I can just do it. Alright. Okay, that's a lot better. Anyway, now let's look at this thing here. Free B2 OR. So free B2 OR. Okay, so what does this mean? Let's tackle this step by step. First thing we can do, we can read in this free. We can say, okay, whatever comes after this, we have to repeat 3 times. But because a bracket comes after this, what we do here, we read through, find the end bracket of this, and then anything inside, we repeat 3 times. We take that and do that sequence 3 times. Okay, and in this sequence, this is B2 OI. Well, we do the same thing with this sequence. B comes first. So what we do for each time we iterate over this, so we iterate over 3 times. So the first thing we do each time is to do a break. So you take the first card and move it to the last section. And then we read them as 2. So what we do here, we check the next character in this case is a bracket. So we find the bracket expression and repeat that, and take that as the expression and repeat it 2 times. So for 2 times we do out shuffle, then in shuffle. And the output of this should be 1, 6, 3, 2, 4, 5, 7, 8. Alright, so we've got a rough idea of how this should work. I mean, it's a question 2, so the actual difficulty will be encoding it rather than the logic, right? I suppose the main problem here is how do you detect brackets? And one of the reasons this actually took me a long time to code is because I didn't actually pay much attention to this in the first time I was doing it. So what I did, I just took in my string, I iterated over the characters, so I did for I in input. I then just simply execute instruction. If bracket ignore, and if number, repeat next instruction x times, whatever the number is. And obviously this was not going to work because brackets can change the meaning of the expression completely. So what I actually ended up doing was I defined a function. So here's my function. And what this function did, it took in list of operations. So this is just whatever we inputted originally. And then I said, I did pretty much a similar thing as before, at least at first. So if it's not number or bracket, simply remove that from the front of the list or front of the string and execute instruction. If it is a number, well then that's where things get interesting, right? So if it's a number, we check remove next item of the string. And if it was a bracket, oh no, let's take the case where if it was an instruction, like BIO, what we simply do here is say execute instruction. Execute instruction X amount of times. Then, if it was a bracket, find closing bracket, and I'll go more detail into this once we start looking at the code. And then go back to this function, call it again. But instead of this list of operations, which is our initial, we put it as a parameter, the sequence of instructions between the brackets. So we get the sequence of instructions between two brackets. And then feed it back into our function. And then repeat this like x times again. And repeat x times. And I think that actually covered most. At the time, I thought this covered everything, and in fact it did. So let's go over to the code and see how it works in practice. Alright, so you can see here is the code. We get the input value, which I've just taken as the input and then stripped it to remove any trailing white space. We have our card, which is going to be our list, just a list of numbers 1 to 8. And then here's the function that I define, execute instruction set. So first I say, okay, we're going to use this global card variable, and I turned instructions into a list because it makes it easier for me to iterate over. And then I say, while this instructions list exists, so I remove the first item from the list and store it in a variable called instruction. Then I then check if it's one of these letters B, I, or O. If it's B, then I remove the first element of the array and append it to the end of the class. And that's fairly simple. If it's I, then I just take values at positions 4, 5, 6, and 7. so the last four elements, and then shuffle them inside. So it's before the cards 1, 2, 3, 4 respectively. And if it's O, I basically do similar thing with I, except I take card 1, then card 5, then card 2, then card 6, etc. Alright, else, if it's not B, I, or O, it's going to be a number in this case. And that's because I take care of all the brackets instructions inside here. So you're not going to read bracket, and you're not going to only read a bracket because because brackets only come after numbers anyway, so that's fine. So I then take the integer value of the instruction and store that in the variable num. I then take next char, so I check what's the next character in the string or list of instructions, and then I remove that from the instructions. If it's B, then I repeat it. I repeat the B instruction num times, so the amount of times that this number says, for example, 3 says. If it's I do a similar thing, but with the instruction for inner shuffle, inner riffle, and if it's O, I again do the same thing, just iterating over the range of the number. Else, we found an open bracket. So you can use the fact that each open bracket has a closing bracket associated with it. I mean, that makes sense intuitively. If you have your instruction and there's no end to the bracket, the instruction hasn't ended, right? So if we find an open bracket, we use the fact that the open bracket is closing bracket associated with it. We define closed bracket count to be 1. This counts how many more closing brackets need to be found. And we have our new instruction set here. And we say while closed bracket count is greater than 0, we get the next instruction in the instructions list. We see if it's an open bracket. If it's an open bracket, what we have to do, we have to increase the closed bracket count because now we need to find more closing brackets because one complex instruction will be entirely contained within another closing instruction. It won't be the case that you will have one straddling another because that doesn't work in brackets. So we will need to be finding one more closing bracket, and we add this to the new instruction set. And then we say, okay, if it's a closing bracket, we check if there's only one more to be found. If there's one more to be found, that's the last bracket. We won't need to pass that bracket to our function because it's not actually doing anything in the instruction. So it's only if it's not one. So if we need to find more than one closing bracket, i.e. there is another complex instruction inside our instruction. So let's say this instruction. Over here, when you're here, the bracket count be set to 1, and then when you're here, the bracket count be set to 2, and here the bracket count. After this bracket, the bracket count will be 1. And obviously, this closing bracket does actually influence the outcome of this expression. So we need to add that to our new instruction set. And then we decrease the closing bracket set count by 1. And otherwise, we say the new instruction set, we add the instruction to it. So it's, in the other case, it's either going to be a number or a letter, and in which case we just add it on. And then after that, we've got some next instruction set. So let's say we were going over this. We would have gone through from this bracket to this bracket, and then the values we'd have stored in our new instruction set are these values set. And then what we want to do is execute that new instruction set. And we want to do it how many times? The number that's kept before the brackets. So this entire thing here is repeated 3 times in this example. And because it's editing cards directly, and the only thing we're outputting is cards, I don't actually need to return anything from this function. So what I do, I execute the instruction set of the instructions, and then I print the array, which I have just converted to string and formatted it so that the headspace is between. And we can see this works. If we input the first instruction, first example, I to O, we get 5, 6, 7, 8, 1, 2, 3, 4, which does indeed match what we're given here. And for sample run 2, let's do that. 3 of B, oops, B2, oh, B2 and OR. And that does give hang on a minute, let's run that again. Let's just copy it over directly this time. Let's just copy that, paste that here. And yeah, we do get 1, 6, 3, 2, 4, 5, 7, 8. I think what happened before, why it showed 1, 2, 3, 4, 5, 6, 7, 8, is because I confused it by removing and adding characters. Alright, so you print that, and that all works very nicely. If you have any doubts or you want me to go over any other questions, please post it below in the comments. If you have any suggestions on how I may improve, I'd appreciate them. And if you enjoyed this video, please like and subscribe. Thank you for watching.